Everyone, students, in this video we're going to be taking a look at some of my favorite properties of real numbers. These properties of real numbers have been used even by us this year already to simplify expressions, and that's what this lesson is all about, focusing on the properties of real numbers that we've used, especially like the commutative or associative properties. We've used the commutative and associative properties already. But we're going to find out that there's some more properties. Most of these are actually really easy for us to deal with, and we're going to use them to simplify expressions. So what are the properties that we have to work with? Well, first of all, we have the identity property of addition. For every real number a, if we add 0 to that number, it's the same number. That's the identity, just means we're getting the same number out, okay? So if I add 0 to 5, for example, I get 5. Adding 0 gives me the same number. The identity property of multiplication functions in sort of the same way. What do I have to do when I multiply to get the same number? I multiply by 1. So for every real number, a times 1 equals a. Interestingly, both of these properties apply to all real numbers, so this could be for rational numbers or irrational numbers as well. Negative numbers even, doesn't matter what you plug in for a, this will work. All right, the commutative property. We've used this before, even if we didn't call it the commutative property. And what it means is that it doesn't matter which order you add numbers. You can move things around when adding numbers and still get the same result. A plus b equals b plus a, or 5 plus 2 is the same as 2 plus 5. Order does not matter when adding. The same is true with multiplication. A times b equals b times a, or AB equals BA. Notice the two ways that our book shows multiplication are down here. Letters next to each other or letters with the dot symbol in between. 5 times 2 equals 2 times 5. It doesn't matter which order you multiply, you'll always get the same result. The associative property means it doesn't matter what order or how we group multiple numbers being added together. So notice this involves numbers a, b, and c. I have 3 variables representing numbers a, b, and c. And it doesn't matter if I add a and b first and then add c, or if I add b and c first. Notice this on the other side of this equation. I have b and c in the grouping symbol and add a. It doesn't matter what order I do the additions. I'm always going to get the same answer. Now this is a little different from commutative because here I'm actually changing the physical order of the numbers and putting b before a. Notice that down here, the order of the variables stays the same, ABC, ABC. But I'm just changing the order that I do the additions with the variables in that order. So now here I'm doing a plus b first, but on the other side I'm doing b plus c first, and it doesn't matter. So here's the example, 1 plus 2 plus 3. If I do 1 plus 2 first, I get 3 plus 3. It equals 1 plus 2 plus 3. If I do 2 plus 3 first over here, I get 5. And 3 plus 3 is the same as 1 plus 5. They both equal 6. That's the associative property. Now here's the way to remember that. I'm associating terms with each other with parentheses. Okay, and it doesn't matter which terms I associate together. I'm going to get the same result regardless. Let's take a look at the associative property of multiplication. Guess what? Same property. It's just now I'm multiplying numbers instead of adding them. It doesn't matter if I multiply a and b first and then do c, or if I multiply b and c first and then multiply a. Irregardless, I'm going to get the same answer. Here's the example. 1 times 2 times 3. 1 times 2 is 2. 2 times 3 is 6. 1 times 2 times 3. 2 times 3 is 6. And then I multiply by 1, I still get 6. All right, let's take a look at some practice problems here. For the first ones, I don't actually have to solve anything. I just have to identify the property that's indicated. So let's start with those. For number 1, for letter A, notice that I am associating 9 plus 8 on the left and 5 plus 9 on the right side of this equal sign. That is a textbook case of the associative property of, and here I'm adding numbers, so it's addition. All four words are extremely important when answering these questions. Number 2, I'm adding something to 10 and still getting 10. That's the identity property of addition. Letter C, 15 times 3 equals 3 times 15. I'm actually physically switching the order that I'm multiplying two numbers together. That's the commutative property of multiplication. And then letter D, 17 times 1 equals 17. Up, same number in and out. That's going to be an identity property. This is the identity property of multiplication. All right, let's take a look at letter E. Tell whether each statement is true or false. Justify your answer using the properties. Assume all variables represent real numbers. AB times C equals A times BC. That is true because of the associative property of multiplication. All right, letter F. Here I have M minus Z equals Z minus M. That one is false because it would have to be the, let's see, that would be the commutative property of addition, but it's not addition, it's subtraction. Now remember, all subtraction is addition. I could change this to an addition problem. Would it be the same though? M plus negative Z equals Z plus negative M. Is that correct? Well, just take a look at this. Here on the left, I have negative Z. On the right, I have negative M. These two are not equal to one another because I have the different number as an opposite on either side. So I'm just going to go ahead and put a slash to that equal sign because those are not equal values, okay? So that's why that one is false. I cannot actually state that that is a commutative property of addition because there's different values on the left and the right-hand side. However, if on the left it was M plus negative Z equals negative Z plus M, that would be a correct commutative property. All right, the key here is the commutative property does not work for subtraction, just for addition. And then lastly, letter G, W plus 0 equals W. That is true by the identity property of addition. All right, letter H, simplify each expression, justify each step. Here we have 18 plus 7x plus 4. Now, what I'm going to do with this one, I'm going to reorder this to make it 18 plus 4. Let's just I'm going to put the 7x first, okay? So let's see. I'm just going to put a double arrow here, a triple arrow to show that I'm doing the same problem but over to the right. And I'm going to rearrange it to be 7x plus 18 plus 4. I'm going to put my variable term first. And then I just moved it around. This is the commutative property of addition. Commutative addition. All right? Let's just make this a little wider so that fits on one line. So use the commutative property of addition. The next thing I'm going to do is combine like terms. So it's going to be 7x plus 22. And that's the most that I can simplify this one when I put 18 and 4 together. So if I was justifying this, I would say I'm justifying by combining like terms or adding the constants or something like that. All right, letter I. 1/3 d times 3. Why, I can rewrite that. So 1/3 d times 3, that becomes 3 times 1/3 times d, okay? That's the commutative property of commutative, and that's multiplication. All right, so looking at this a little bit further, 1/3 times 3 is 1. So this is going to be, I'm going to multiply the 3 times 1/3. I'm multiplying like terms. 3 times 1/3 is just 1. So the answer to this one is just D. And that's multiplying the constants together. All right, and then lastly, letter J. Let's see what happens with this one. Okay, so in J, I've got erasers, markers, and papers purchased at the school store for the following prices respectively: 145, 335, and 265. Find the total cost of supplies, justify each step. Okay, so as I look at this, it's going to be really hard to add them in the order that they're presented. But I'm just going to notice that 265 and 335 are really easy to add because they add up to a whole dollar amount. So I'm going to do that first. I'm going to do $335 plus $265. I'm still going to have to add to that $145. And this is the commutative property that I wrote it in a different order. Now I'm adding three things together. Let's just make this wide enough to fit here, even though it goes off the page a little. Okay, what I'm going to do is I'm going to associate together $335 and $265. Okay, I'm going to associate those together with parentheses, and it's still going to be plus $145. This is the associative property of addition. And then let's see. Oops, I put a K there. I didn't mean to do that. All right, so now I'm just going to add 335 plus 265. That's going to be $4, $5, $6. So this is going to be $6 plus 1.45. And at this point, I'm just adding like terms. So 6 plus 145 is going to be $7.45. Now that felt like it took a lot longer just because I explained everything. But if you had three numbers to add together, you probably wouldn't add them together in the way that gives you partial dollars. If you could add them in such a way that you can make whole dollars with some of the numbers. And why are you able to flip numbers around like that and add them in a different order? Well, it's because of the commutative and associative properties of addition. All right, now you have all of the tools you need to go ahead and get to work on problem set 1 through 30.